For CCS to deliver on its promise of reducing CO2 emissions, they must be safely and permanently stored underground. By injecting CO2 underground, we are in effect returning carbon back to where it came from. We extract carbon as coal, gas and oil, which are burnt to produce energy. The resulting CO2 emissions from power plants and heavy industry can be captured before being pumped underground, closing the carbon loop. How do we store CO2 safely and permanently underground? By imitating trapping methods used by nature to store CO2, gas and oil for millions of years, and by using existing technology to transport and inject the CO2. Technology which has been used for decades by the oil industry. Storage starts by pumping liquid CO2 into a carefully chosen reservoir. There are two main types of CO2 storage reservoirs: deep saline aquifers, which contain undrinkable salt water, and depleted oil and gas fields, both of which have the same key geological features to safely store CO2. A suitable CO2 storage reservoir needs a layer of porous rock at the correct depth to hold the CO2, sufficient capacity, and an impermeable layer of cap rock to seal the porous layer underneath. Once the CO2 is trapped under the cap rock, three additional mechanisms, residual, dissolution and mineral trapping, ensure that the safety of CO2 storage sites actually increases over time. How do these mechanisms work? Some of the CO2 injected into the smaller pores simply cannot move, even under pressure. This is residual trapping. A portion of the CO2 dissolves into the salt water. This is called dissolution trapping. The CO2-rich water is heavier than the surrounding liquids and migrates downwards, where it may react to form minerals such as those found in limestone. This is mineral trapping. To ensure that a CO2 storage site functions as it should, a rigorous monitoring process begins at the reservoir selection stage and continues for as long as required. The well, cap rock and adjacent rock formations are monitored for changes in pressure and CO2 concentration levels. All of these systems ensure that response times are swift and decisive action can be taken when necessary. Monitoring continues even after a well is closed, and EU law requires